Hi everyone and welcome to this my lesson on types of stationary points for the mathematical methods units 1 and 2. Of course, my name's Darren from Maths Guru, as it says probably on there, and it's really good to see you. So basically, let's get straight into this stuff. If you watched all my previous videos, you know that I'm going to ask you to subscribe to my YouTube channel, which would be massive, and spread the word. Why are you subscribing? Well, basically, no one watches maths videos. And when you hit subscribe, it just lets me know, hey dude, I've watched your video. That's all that matters. Turn off notifications if you don't want to hear from me ever again. But it's fine. Now, as always, I put the learning objectives behind me. This is building on from the previous video where I talked about, turning points and whatever else. This is now types of turning points or stationary points. And we're going to look at local maximums, local minimums, the stationary point of inflection, and also the terminology behind a turning point. Right. Now, again, past learning, we've looked at what it meant to be a stationary point. All right. Basically, it's a point where the gradient of the tangent at that point is 0. Okay, so we've learned all sorts of different ways of being able to do it. Probably I told you in previous videos that my maths teacher made it do it by hand with pencil and a ruler, but that's okay. I'm over that therapy now. And we discovered that there were 3 main places on a function where there might be a 0 gradient. So again, this is more a recap and sort of being able to find where they are, and also different ways. And I'm going to branch out into the methods 3 and 4 course as well, a little bit of special actually. Don't worry, it's not going to get too much for you, I promise. So recap, what is a stationary point? Well, if I was to actually label it here on my diagram, it would be probably around there. Because if I was to draw a tangent at that point and work out the gradient of that tangent, it is going to be 0. A horizontal line has a gradient of 0. Why? Because there is no vertical rise for any horizontal movement. And again, that sort of comes back to our year 9 mathematics, doesn't it? Where we say, oh, gradient is rise over run. Yeah. So we're looking for where there is absolutely no rise for any run that we make. So that's fairly obvious. Now, methods is about terminology, and getting the right terminology becomes really, really important. So we got maximum and minimums. And what I want to do now is just make sure that you understand the idea here that there is a local maximum and minimum, and there's also an absolute. Now we're going to look at the idea of local maximums and minimums in a moment, and it says it is the point within an interval at which the function has a maximum value. Now at this moment in time, if we look at this graph here, is that the whole function? No, we don't know what the rest of the function looks like. It could go up and then down and up and down. It could go. It's probably not going to do what I just did there. But the point of it is we don't know. We only can see at this moment an interval somewhere between -3 and 4, thereabouts. So this point here would be described as a local maximum. This point here would be a local minimum. Why? Well, that is the maximum point for there. All right, so that's a maximum because the graph seems to go up and then back down again. And that'd be a local minimum, which comes down and goes back up again. And again, terminology becomes really, really important. All right, and we're going to look at the idea of the differential, because we know that that's how we find the gradient of the tangent at a point, by taking the differential of that function. So this is all building once again. All right, so the absolute maxima, as it says here, is the idea of a global maximum and is the point across the entire domain of the given function. So if we actually knew that this was a cubic, right, where is my absolute maxima, right? It's going to be the maximum value that thing ever gets to. And if that goes off to infinity and beyond, then the chances are that would be infinity, and likewise there would be negative infinity. But that sort of strays a little bit outside, right? So we've got maximums and we have minimums. What about stationary points of inflection? And again, the language is really, really important. Stationary point of inflections. Lots of people don't want to go, it's just a point of inflection. My understanding is it's important to write the word stationary point of inflection. But here we can see the graph of y equals x cubed, right? That becomes one of those standard graphs that we get to know over and over again. And we know that that point there goes through 0, 0. And we also know that if I was to take the gradient of the tangent at that point there, okay, and only this point here, then my gradient would be equal to 0. Now what we notice is all of the gradients here, if I took a gradient of any point up to and including that point there, so a gradient there, and a gradient there, and a gradient there, or the same on this side here, the gradient here, the gradient here, the gradient here, what we would notice is that every single one of those would have a positive value, except for this value here, which would be 0.